Hello, in this video we are going to go over the solution of the problem 103, binary tree zigzag level order traversal, and we are going to use BFS. Imagine that we are given a tree like this one, and we want to get the result something like this. For each level of the tree, we are going to visit the nodes. For example, on the first level, H0, I'm going to have a list that has a node 2. For the second level, H equals 1, instead of having 1, 6, I'm going to put 6, 1 because it is a zigzag pattern. For the next level, H equals 2, it should be 4, 7. And finally, for H equals 3, last layer, it should be 3, 5. Okay, let's start writing the code. As we are going to use BFS, the first thing that we do is to import DQ. From collections, import DQ. And then I'm going to define a variable for Q and say Q equals DQ. And I add root to that Q. Okay. After that, we can go forward and visit the next level. For example, root here is 2, and then we use BFS to visit 1 and 6. So for doing that, we say while Q. Then I'm going to pop left the nodes from the queue and add that to the list that I want to return at the end. And also add the children of each node to itself. For example, for the root node, I have 2. So I should add number 2 to the resulting list that I'm going to return. And also I should append 1 and 6 to the queue. So for doing that, so the first thing that I'm going to do is that I'm going to go and visit all of the nodes in the queue. We say for I in range of length of queue. Why length of queue? Because length of queue could be different. At the first level it is 1. At the second level is 2. And we are going to go forward and pop left them one by one. And I say node equals q dot pop left. Okay, now I have the node. I can go forward and append the neighboring nodes. If node dot left, it means that if node dot left exists, I append that to my queue. In a similar manner, if node dot right exists, I append that to my queue. Let's say I have a list that I want to return at the end. I called it at the beginning as zigzag result. And that's an empty list. And at the end, I'm just going to return this. Okay, we are going to return zigzag result. And zigzag result is a list, something like this. Now I'm going to create its elements like 2, 6, 1, 4, 7. And each one of them is also a list. But we should consider that for the odd levels like H1, the order of that should be reversed, like 6, 1. Okay, for doing that, the first thing that I need to do is that I need to know the height of the tree. So I'm just gonna use H here. And as far as I'm in the while loop, I'm gonna increment height. Okay, H equals 1. The next thing that I'm gonna do is that depending on what height we have, we are going to create this list in a normal order or in a reverse order. And we are going to use a temporary queue. I'm going to call it TMP queue level node. And at the beginning of each while loop, that's an empty, the queue. Okay. Now we are in the for loop. If level is even, so we say H divided by 2 if its remainder equals 0, which means that is an even number. So we just say tmp q dot append, and we just append the node value. And else, if it is an odd number, for example, h equals 1, that I need 6, 1. That is a reverse. So you see here. So h equals 1, I need 6, 1. So for doing that, we say tmp dot append left. Note that way. Okay. For example, we are at h equals 1 and we are conducting this for loop. So first I is 1. It's going to be added to our queue. And the next one, when we are going to add 6, is going to append left. The result of that will be 6, 1. So using this trick, we are able to create these lists in a reverse order if the height is odd. H is going to change in the while loop, so it should be 1 behind. H is correct here. And now, at every iteration in the while loop, I'm going to save the resulting of that temporary queue in a dictionary. And I'm going to say this. First, we define an empty dictionary. We say D equals empty dictionary at the beginning. And we say D of H equals TMP queue level. Okay. We are adding that value to our dictionary. And let's see what happens, because for example for H0, when we are at the root, so our dictionary with the key 0 gets the value of that temporary, which is 2. And then you see here we are emptying that. So because every time in the while loop that gets empty. So next time TMP level node will be 6, 1. And then for D with the key 1, we get 6, 1. Okay? And so on. At the end, out of the while loop, we can just turn that dictionary to a list that we are returning. We say for key and value in D dot items, we are going to say zigzag results dot append list value. And the reason we are putting a list here is that if you remember, this temporary is a queue, but I want to return a list like this. So I just convert that to a list. Okay, let's run it. And we get this result 2, 6, 1, 4, 7, 3, 5. Okay, now let's talk about time and space complexities. For the time complexity, we are conducting a BFS. So we have a time complexity of order of n. Also, we have this reading the values from the dictionary and put them in a list format. For that one, we are also going for all of the items of our dictionary, and for all of the items, we know those are the heights. That's going to be the order of the height of the tree, which is less than n. So at max, our total time complexity is order of n. Our space complexity is also order of n because we are creating a queue to record all of the nodes, and for recording those nodes for the main queue that we had, that's not going to go over n as the number of nodes. Also, this temporary queue we made, that's going to be just the size of each level, which is definitely less than n. And also the dictionary we made, so dictionary is going to store all of the elements of the tree at max, which is order of n. So as the result, the space complexity is also order of n. Okay, this is the solution of the problem 103, and thank you so much again for watching this video.